In this experiment, we will try to understand a transistor. Transistor is a device that revolutionized the electronics industry. It can control a big current using a small current. That is how it works, and it is a 3-terminal device. Here you can see we have a transistor with 3 leads. One is called emitter, and the middle one here is called base, and the collector. And how it works is, suppose say I connect a power supply, like apply a voltage to collector, between collector and emitter, and the current flow will depend the amount of current which will be put into the base. That means, using a small current in the base terminal, you can control a large current across the collector emitter path. So, we will try to do this experiment using this X-Spice kit, and we will use the following terminals. Like here you can see this OD1, this can be used as a power supply. You can set it to 5 volt, and that will act as a power supply. And this PVS, our programmable voltage source, that we will use for controlling the base current, and we will monitor the collector voltage. So, let us make the connections. Like the emitter, this terminal will be grounded. Now, let us ground this terminal, and the base should be connected to this programmable voltage source, but it should be connected through a large resistance. So, we will use a 200 kilo ohm resistance to do that. So, the base is connected to PVS through a large value of resistance. Now, the only thing left is our collector terminal, and the collector terminal should be connected to the supply through a resistance. So, we will take a 1K resistor, and that is the collector resistor, and that gets connected to. So, this completes the connections. So, if you look at these connections, here you can see the 5 volt coming out of OD1, that is connected to the collector through a 1K resistor, and the base terminal is connected to the programmable voltage source through a 200 kilo ohm resistor, and emitter is connected to ground. Now, let us see how it acts, and if you assign in1 to channel 1, it shows the voltage across or voltage at the collector. And now, it is 0 because the supply has to be switched on. So, we tick OD1, and you can see it is at 5 volt. That means, the entire 5 volt applied is appearing at the collector of the transistor. That means, no current is flowing. So, we have to apply some current to the base. That is possible by putting some value at PVS. So, PVS is set to now 2 volts. Now, you can see the in1 has changed to 3.47. That means, some current is flowing. That the current can be easily calculated. Whatever current is flowing, that creates a voltage drop of 1 kilo ohm into that much current, and the remaining voltage we are seeing here at the collector of the transistor. So, we can change this to say to 3 volts. So, that change the collector current again. So, you can see the voltage across the voltage at the collector has changed again. So, this way, by controlling the base current, we are able to change the collector voltage. So, by changing this, we have set this voltage up to something like at the half of the value now, 2.3 volts, and total voltage is 5. Suppose say at the base, like look at the screen here, we have not connected any signal here. I mean, this part is not connected. We have applied a voltage here, and some base current is set, and voltage at this point is now something like 2.3 volts. Now, suppose say if you add some small signal here, very small signal here, that signal will appear here in an amplified form. So, what we will use is we will use a small microphone, and that signal will be amplified and shown here. So, the microphone should be connected to this junction through a capacitor, because this whatever DC voltage is established here, that should not be disturbed. So, the DC isolation is provided by this capacitor. So, let us make this connection also. So, this is our microphone, like actually it is a small loudspeaker, but that will act as a microphone. So, one end of that will connect to ground, and the other end should come to the base, where we already have this 200K resistor sitting. So, we made that connection, and now you can see, if you watch the screen, I will blow some air into this microphone and see how this waveform changes. So, what you are seeing is whatever this input to the microphone induced a small voltage, and that is amplified this by this transistor circuit. But probably we can make another sound source and get a clean signal. We will use a buzzer, like you can see a buzzer, and power it by a 3-volt battery. You can see we have a clean signal of a well known frequency, and you put this in front of this. So, now the sound from this buzzer is captured and amplified here. So, you can see on the screen you have an AC signal at around say 2.5 volts superimposed on our DC operating point. If I remove this sound, that becomes a DC signal on the screen, and if you apply this, you again see that AC signal is appearing. This is how you make an amplifier using a single transistor. So, now we have seen how to make a simple transistor circuit using one transistor and two power supplies. One is a fixed 5-volt supply, and another one is a base supply, which we changed to set the operating point, the DC operating point. Then we amplified an AC signal generated by a microphone using this amplifier.